All right, so where we last left off with quadratic functions is we learned what vertex form was. What is vertex form, by the way? Remember? What's the first letter I write?
Y.
Got that? False. What's the first letter? A.
Grammar days. X minus.
Good. Okay. So that's vertex form. And really, the reason why we call it vertex form is because when we graph these things or when we state their properties, we always look to the vertex to help us. Okay? So remember, when it's in vertex form, HK represent the vertex, the coordinates of the vertex. So this is the X vertex. This is the Y vertex. And then A represents whether it goes up or flips upside down, and whether it stretches. Okay? So when we had it in vertex form, we were able to state all the properties of quadratic functions as well as graph. But a lot of times, quadratic functions come in this form. And there's actually a reason for this form that we'll see in the next unit. This is called standard form. And by the way, A can never be 0, because if A was 0, then you would no longer have an x squared. It's no longer a quadratic function or a parabola when you graph it. Okay. So we're going to start working with this form now. And one other thing before we start moving on, quadratic functions, we refer to them like we refer to expressions that have exponents by their degree. The degree of an expression, it's the highest exponent you see in the expression. Highest exponent. In an expression. And quadratic functions are always degree 2 because it contains an exponent of 2. That's the highest. Nothing higher. So just as a little bit of practice, which of these are quadratic, which of these are not? Has to have an x squared, can't be higher. How about the first one? Yes or no?
Yeah.
Yeah. Next one?
No.
No. Because it's got an x cubed. That's a different type of function that we'll talk about next year. Okay? How about this one?
No.
No. Because it's got a variable exponent. Can't have a variable as an exponent. Next one?
No.
No? Does it have an x squared as its highest? Yes. And this one doesn't happen to have an x term, but that's okay. Still quadratic. There's no funny looking exponents. Highest exponent is 2. Next one's a little tricky. No, what's throwing you off? Like what looks weird here? You got a choice of two. Which one looks weird, x squared or root x? Which one haven't you seen? Root x. Okay? No, because remember how to write square root as a fraction, as, well, I gave it away, as an exponent. X to the, do you remember square root of x is the same as x to the, you learned it last year? 1/2. Can't have fraction exponents. How about the last one?
Yes.
Yes. Because if you were to actually multiply all this out, you get an x squared as the highest exponent. 2 would be the highest exponent. So yes. Okay. So that tells you what is and what isn't quadratic. If it's got an x squared in it and nothing higher or no fractions or no negative exponents, it's good, it's quadratic. We're used to seeing functions in vertex form. This time, we want to write it in standard form. We want to make this look like this. How do we do that? Let's multiply it all out and simplify it. What does x minus 3 all squared, what does that mean to do? When you're asked to take x minus 3 and square it, multiply it by itself. So x minus 3 all squared means x minus 3 times x minus 3. And you still have a minus 7 at the end. Now let's multiply this out. 4 multiplications, so x times x is x squared. X times minus 3 is minus 3x. Inside, minus 3 times x is minus 3x. And minus 3 times minus 3 is plus 9. And don't forget, there's still a minus 7 here. We can simplify some things. If I collect the x's, what do I get? Negative 6x. And if I collect the numbers?
+2.
Plus 2. That's standard form. Because it looks like this. It's got an x squared, doesn't have a number in front of it. That's okay. The number's actually 1. It's got an x term. It's got a number. Okay. So it's pretty straightforward to go from vertex form to standard form. You just square that binomial, simplify everything by collecting like terms. Try this one. You try this one. This one is not really in any form right now. It's not in vertex form. But it's not in standard form. So you should recognize to multiply it out and then simplify everything you can to make it look like something x squared, something x, and a number. So if we multiply these two by each other, we should get 12x plus 8 minus 3x squared minus 2x. And then there's still a plus 2. Now we have to collect like terms if we can and put it in the right order. The x squared term goes first. So minus 3x squared will go first. 12x minus 2x makes plus 10x. That goes next. And then the simplified number goes last, plus 8 plus 2 gives me plus 10, and now I'm in standard form. Now, standard form is useful, but vertex form is actually better for stating all the properties. Okay? We'll see, like I said, we'll see in the next unit why standard form is useful. Because it helps us, when it's in standard form, it helps us solve a lot of different types of problems. But vertex form helps us solve a lot of different types of problems. The only problem is it's difficult to state properties. Just this, what form is this in? Standard or vertex? Standard. Tell me as many properties of this as you can. Can you tell me the vertex? No, why not? Because it's not in vertex form. So you can't tell me what the vertex is. What can you tell me? Anything? Anything? A's not 0. Yes, opens down. That negative tells me that it opens down. Think of all the other properties we did. So we can't find the vertex in this form, which means I can't find the axis of symmetry. I know that there's a maximum because it opens down, but I don't know where it is. Okay? Can you tell me the domain? Negative infinity to infinity. It doesn't matter what form it's in, domain is always this. Range? No, because I need the vertex to help me, right? I need to know where does it top out, but I don't in this form. Anything else? How about the y-intercept? That we could find. Because remember, with the y-intercept, we just make x equals 0. So we would get negative 0 squared minus 7 times 0 plus 3 works out to 3. That's pretty much it. Okay? So if I have something in standard form, it's going to be hard for me to state all the properties. If it's in vertex form, I can. So now what we're going to do is, how do I go from this back to this? Okay. We talked about how to go from vertex to standard. Just square it, simplify. But how do we go backwards? So here's our example. How do I make this look like this? And we're going to, you can see here, obviously, that the method we're going to use is called completing the square. First thing you have to know is what's a perfect square trinomial? Well, let's take a step back. Do you remember what a perfect square is? Or can somebody give me an example of a perfect square? Why 16? Because 4 times 4. Okay, so a number that equals another number times itself. So yes, 16 is a perfect square because 4 times 4. 100 is a perfect square because 10 times 10. Doesn't necessarily have to be numbers. X squared is a perfect square because x times x. X to the 6th is a perfect square because x to the 3rd times x to the 3rd. A perfect square trinomial is a trinomial that can be written as a binomial times itself, or a binomial square. Itself means the same thing as square. That's a perfect square trinomial because there is a binomial times itself that will give me this. How would you find it? Excellent. Outstanding. You have to factor it. Well, remember this type of factoring? We're looking for two numbers that add to 8 and multiply to 16. And that would be 4. Or x plus 4 squared. Notice when it's in this form, it's part of vertex form. If I gave you this one, this one is equal to x minus 5 times x minus 5, or x minus 5 all squared. What I want you to do is, can you see a relationship between the numbers in the trinomial and the number in the binomial? The numbers in the trinomial and the numbers in the binomial? Can you see a pattern? 8 is, how can I get 8 using 4s? Yeah, 8x, that's 4 and 4. Minus 10x is minus 5 and minus 5. So whatever perfect square I give you, perfect square trinomial, when we factor it, this number will always be half of this. Always. Do you notice anything about this number and the numbers here? Yeah. This number is this one squared, or the square root of this one is this one. The square root of 25 is minus 5. Okay? We're going to use that to help us factor these things. So here's how we do it. First of all, we're going to take this, I'm just going to change it to y. Remember, y and f of x mean the same thing. I'm going to write the first two terms, and then I'm going to write the third one out here because I'm not using it as part of completing the square. What number could I add to these two to make a trinomial? 64. 16. Because remember, half of this is 4, but then 4 squared is 16, right? This is half of this. This is this squared. So how do I find the number that makes it a perfect square? I take half of 8 squared. Half of the x term squared. But I added a 16, didn't I? I just changed it. What else can I add to it to cancel out the 16? What will cancel out plus 16? Minus 16. So I need to add this in order to factor this, but I can't just add it without subtracting it, because this, in effect, I've added nothing, have I? I've just put in a couple of numbers that's going to help me factor it. So now, let's factor this, and it's going to be squared. What's it going to be? X plus 4. These two numbers I can just put together to make negative 11. This is now vertex 1. So you just completed the square to put it from standard form into vertex form. And now that it's in vertex form, I can answer a whole bunch of questions if I want. If I ask any here, no. Like if I asked you here, what's the vertex? What's the coordinates of the vertex? What's h? Not 4, it has to be in subtraction form. Negative 4. What's k? Oh, negative 11. So the vertex would be negative 4, negative 11. And then we can get all our other properties from that. Okay? Remember, that's the first one. We're going to do some practice here. Let's try this one. So I want to put it into vertex form. I'll use f of x. If you use y, it's still right. The x squared term and the x term, put them together. Put the number off to the side because it's not part of the completing the square. Now I have to figure out what to add and subtract to make a perfect square. How do we find out? Half of this, which is, careful, and negative 5 squared. Negative 5 all squared, positive 25. And to keep it balanced, what do I have to add on top of that? Negative 25. Good. So it's half of negative 10 squared. Now that we've added and subtracted the number we need to factor, let's factor. X minus 5. Don't forget the square. And then these two make? Subtract 26. We just completed the square. What's the vertex? Careful. Positive 5. Negative 26. Remember, it has to be in subtraction form to read h. So if it's x minus H is just this number. If it's x plus, H is the negative of this number. And what's the axis of symmetry? Remember how to find that if we know the vertex? X equals 5. It's just the x vertex. Okay. Before we move on to the next one, I do want you to try, I'm just going to add one to try on your own. Try it out. What do I add and subtract? Plus 9 minus. This is the part that gets factored. What's this factor? X plus, yeah, squared minus 6. Good. Okay. Okay, one little wrinkle. What happens if there's something in front? All these other ones we just did, it was x squared, which means that there was a 1 in front. We just didn't write it. How do we deal when there's a negative in front, or a number in front, or both? Okay? Here's what we have to do. I can't, don't write this down yet. I don't know how to factor this when there's a number in front, okay? Or a negative in front. It has to be just x squared. So what do I need to do to make it just x squared? I need to, you're close, very close. We need to factor out -1 from these two, or divide out -1. This divide -1 gives me what? Note this. X squared. This divide -1 gives me -2x. Remember, the -5 is way over here. Now I've got just x squared. Now I can complete the square. What do I add and subtract?
4.
Half of this, add 1, -1. Now, I can't close the parentheses here because I've factored out a -1, so I have to do it like that. Because to remove this, like I can't factor this, all 4 of these. I've got to get this out of here. I want it over here. But when I take it out, it's being multiplied by a -1. So this, when I bounce it out, I got to times it by -1. It becomes +1. So you got to be careful there when you have something in front of the x squared besides 1. Now, keep the -1. I don't have to write the 1. Let's factor this. +1, -1, all squared. And then these two together, -4. And I've got it. Okay, that takes a little bit of practice. We're going to do one more. We're not going to do number 8. I'm not going to worry about number 8. But here, this one. I can't just jump into completing the square right away because there's a 2. So what do I have to do? I have to divide 2 out of these 2, or factor 2. So take out a 2. What's this? Divide x squared, because that's what I want. This divide 2 plus 2x. Remember, the minus 4 isn't part of it. Look on the inside of the parentheses. Now we can complete the square. What do I add and subtract? Plus 1 minus 1, close. I can't factor yet until this is bounced out of here. So to bounce it out, I got to multiply it by 2. And it becomes negative 2. Now it's out. So 2, what's this factor? X plus 1 all squared. And then simplified, minus 6. And we're done. Okay. Don't close it yet, because I do want you to try one. Try that one. Just as an additional practice. Never hurts to practice. What do I need to factor out? 3 of the first 2. What am I left with? Plus. Good. Minus 1 is way out here. Add and subtract. 9. But I got to bounce this out by multiplying by 3. And therefore, what does it become when I bounce it out? Negative 27. So y equals 3. Now factor. X plus 3 all squared. And then combine the numbers. Minus 28. And just for kicks, tell me the vertex. Right. Good.